All right, so we have this roller coaster energy problem that we're going to look at. And for this problem, this is a very classic problem that they give a lot because it tends to only deal with two forms of energy, which makes it simple enough that we can look really like carefully at the math and practice there. The first thing that we're supposed to do is sketch it and identify our system. And our system is going to be the roller coaster itself, the physical object and the Earth. I want it to be the physical roller coaster and the Earth because I want to be able to use gravitational potential energy. Otherwise, I have to talk about the work that's being done by the Earth the entire time. That just tends to be, I don't know, harder to do because I start having weird angles and stuff to deal with. It's so much easier if I just say gravitational potential energy. It's a very easy term. So my system is the roller coaster and Earth system. So with that done, I can now start looking at the types of energy. I have changes in height here, and we can assume that we're also going to have changes in speed. Changes of height mean gravitational potential energy. Changes of speed mean kinetic energy. So I'm going to have those two types. There's no springs, so I'm not going to do anything with springs. And it says to assume that very little energy is lost to friction. I'm also going to leave thermal energy out. I'm just going to look at gravitational and kinetic energy. So let's go through real quick, and we're just going to sketch the energy bar charts. We're not going to stress making things perfect because we're not doing enough calculations at this step to make them perfect. We're just going to get a general idea. So at the initial moment, we definitely have gravitational potential energy. I'm going to call that UG1. Then coming over to moment 2, I'm still going to have some gravitational potential, but I've picked up some kinetic energy. And moment 3, okay, I'm moving a little bit. I'm doing this loop to loop or whatever. I still assume that I have some kinetic energy, but I also have some gravitational. Which one's more, which one's less between 2 and 3 is hard to say at this stage. But I am going to write them with 2s and 3s just so I can keep track who's who. Then moment 4 is a little bit weird because if I said this was my 0 point, which sure seemed like a good thing to do originally, when I get to moment 4, I suddenly have my potential energy is actually lower than what I called 0. Don't let that phase you. It's okay. All that means is I'm going to have a negative value for gravitational potential energy, but gravitational potential energy is a relative term. So it's okay for it to be positive or negative. All that means is how it compares to where you said 0 was. I could put my 0 somewhere else so this doesn't become a problem, but I'm leaving it here so I can illustrate how to solve this. If that's true though, then now I have boatloads of kinetic energy, way more than I had back here, because I have to have actually more energy shown in kinetic energy here than gravitational that I had back here. If I have -1 there, and I'm trying to get 2, then this should be +3. Again, those exact values are going to change once we get some numbers plugged in here, but this gives us a good idea. And finally, at 5, everything is kinetic energy. Not as much here because we don't have that dip. We weren't able to pull a little bit more energy out of our system by going lower, but we're still going to be going at a pretty decent clip. So here's our energy bar charts. To set up our energy equations, we only look at 2 moments at any given time. So I'm going to start with the first and last moment because those are good ones to compare to. I'm going to just write up here in this corner, I have UG1 equals K5. I guess I should have a 5, 4. Yeah. So from there, I can start working some stuff out. I know the gravitational potential energy that I have is mg y1. And I know my kinetic energy is 1/2 mv squared. From there, the masses cancel. It wasn't given to us, but that's okay. We didn't end up needing it. If I want to figure out what the velocity is down here, I'm just going to multiply both sides by 2. So that gives me 2gy1 equals v, which v squared, which means if I square root 2 times acceleration due to gravity, 10 times y1, 20, I'm going to end up with a velocity at this point right here. My velocity is going to be equal to 20 meters per second. And I guess I can also say, I actually don't know exactly how much energy I have. I know that I have mass times gy, but I can't figure out an exact value. Now we know the velocity there. Let's look at some of these other moments. We know that the height here is 20. At this moment here, we know that the height is going to be unknown, but we know that the velocity is 5 meters per second. So we can set up a new equation here. I can use either one of these, it doesn't really matter. I'm going to keep using this one to set up my new energy equation. I'm going to say the energy at moment 1 is equal to my energy at moment 2, UG2 plus K2. This one here is just going to be mgy1, mgy2, plus 1/2 mv squared at 2. Notice again, my masses get to cancel. I know that this is g. Let's say I'm trying to find y2. I know this value, so I'm going to subtract that from both sides. I'm going to go, sorry, I'm kind of running out of space here. Let me move this out of the way, maybe that'll help. All right, that gives me a little bit more room. Let's multiply both, add this to both sides. So gy1 minus 1/2 v squared equals gy2. I can divide both sides by g, and I get y2 is going to be equal to, let's see, 10 times 20 minus 1/2 times 5 squared all over g, that's 10. And this works out to be, unless I messed up, 18.75 meters. That's 200 minus, let's see, 25 minus 12.5. So that's 187 ish, something like that. And then divided by 10, 87.5 or 18.75. Okay, moving on to my next one. If I want to figure out what's happening at this one, I do know the height here. It's 10 meters, but I don't know the velocity. So we're going to try and figure that out now. It doesn't matter which one I use. I guess just for fun, I'll use this one now. So I'm going to say over here that UG3 plus K3 is equal to K5. It doesn't matter which one I use. I could even use this moment. I'm just gonna move around and do stuff. So UG3 is mgy3 plus 1/2 mv3 squared equals 1/2 mv5 squared. If I want to get v3 by itself, I can cancel all the m's. I can subtract gy3 from both sides. So I get 1/2 v5 squared minus gy3. That equals 1/2 v3 squared. Multiply both sides by 2, square root both sides. I get v3 being equal to, I wrote it down because I didn't want to have to do all the math in front of you guys, 14.1 meters per second. Cool. If you don't believe me, go ahead and try and track down the math. All right, let's do this one here. Now we've gone down 10, so I know my height is actually negative 10 meters. So I'm going to use this moment here. UG1 equals UG4 plus K4. That's MGY1 equals MGY4 plus K4. Masses can't, oh, sorry, plus 1/2 MV squared. And so that works out to be masses cancel. I can subtract GY from both sides, GY4 from both sides. And then that's going to be equal to 1/2 V squared. Multiply both sides by 2. I would get 2 times GY1 minus GY4 equals V. Let's just evaluate this term in here. That's 10 times 20 minus 10 times negative 10. That's actually 2 times 300. So that's going to be 600 equals V squared. So if I square root both sides, did I mess up somewhere? I feel like I just messed up somewhere. Oh, I guess I'm okay. Yeah, I think I'm okay. So it's the square root of 600, which is not a number I know off the top of my head. Well, whatever. It's the velocity equals the square root of 600 meters per second. And that's how you do the roller coaster energy problem. So I got lost there at the very end. But hopefully this gives you a good idea of how to set up the problems, how to solve some of the math. Obviously, you can see that I got kind of cluttered on here. But we're going to practice this. You guys are going to do a problem very, very similar to this as a group in class at some point. So thank you guys for watching. I hope this helped you guys.